Guys, welcome to today's class AS Math with Joy. Now, did you know that before all differentiation rules like the power rule, the product rule, and even the chain rule, there was one fundamental method used to find derivatives that is called differentiation from first principle. So in today's class, we're going to be looking at differentiation by first principle. And in this video, I'm going to show you where the formula comes from, what it really means, and how to use it to differentiate functions step by step. If you haven't subscribed to this channel so as to get notifications when our videos drop, please do so right now. Also like, comment, and share our videos. Now, so before we progress into what we have for today, first of all, what is derivative? Now, derivative is simply an instantaneous rate of change or gradient of the tangent. Now, we've been told from your knowledge that when you have a straight line, graph of a straight line, that the slope or gradient at any point on this graph is what? Is constant, is the same, right? Okay, so for any value of y you pick, any y2 minus y1 over x2 minus x1, the gradient remains the same for a what? For a straight line. Whether the line is positive or that, what I mean by positive, negative is whether it is downward or upward sloping. Now, what happens to a curve? What happens to a curve? Okay, now let's start from what we already know, an already existing knowledge. Now, if I have a curve, let's say I have a curve this way, moving this way, probably the curve continues. Now, what happens? For any value of x, the gradient will not be the same. If x is 2, the gradient at x equal to 2 is not the same as the gradient at x equals to 3 minus 1 and so on and so forth. All right. Now, what happens when we have a curve? Now, let's say that I have my x here. Let me trace it down here. All right. So now what do I do to get my slope? So I'm going to draw a straight line that will cut this curve at the point where x is whatever x is given to me to find the slope, right? Good. So now what do? I'm going to trace the change, the spontaneous change along the x-axis as well as that on the y-axis. All right. So now this is x. So moving from here to here, I have a change in x. Now there's a slope here, right? Okay, so let me call it M2. I'm coming. But then at this point, this is point A. At this point, I have x1, comma y1. This is my x1. Okay. Now at this other point of intersection, I have point B. That is where, okay, I have my point B. I have now this in this change from here. I have, okay, let me trace this down to, I have my x2 here, right? Now, what happened before I could get x2? Something happened, right? There was a change. Okay, the slope came out a bit, leading to a change. So a change in the x-axis, right? Now, this slope, remember that this function is for y is equal to f of x, right? Good. So now if this function is for y equal to f of x, now it means that at this point, this value, this is a value for y. This line here moving down can also represent the y-axis. So at this point, we have our x1 here, we'll have our y1 here, which is equal to what? This our y1 is also equal to what? F of x1, right? Good. So now along this line, something happened that gave birth to what? That gave birth to another value for y, as it also gave birth to another value for x. So now at that point, so now for here, I'm going to have x2, comma y2, right? Okay, now let me explain something here. Now, before I could get my x2, hmm, something happened to x1. Something was added to x1, and that was a change in x. Good. So now, since my y is equal to f of x, so that means for me to get my y2, which is equal to what? Which is the same thing as f of x plus change in x. Remember that your x is the independent variable, so it is what affects the y, the values for y. Okay, good. Now that means my y2, which is equal to f of x plus what? Change in x. Good. So that when you see me write use these things, you will not be wondering, what is she talking about? Where is she getting all these things from? So you've seen what my y1 is, you've seen what my x1 is, and all, and so on and so forth. All right. Okay, now we already know that gradient, having known this, remember that gradient, which is m, we said that, remember we said derivative is what? Instantaneous rate of change, or gradient of a tangent. So we already know that the gradient of a tangent is y2 minus y1, change along the y-axis with respect to change along the x-axis. Why is it always with respect to? Because x is the independent variable. Okay, so we're studying change on the dependent with respect to what? The independent, the one that's nothing concern them. That's the x. Okay, so that is why m is equal to change along the y-axis with respect to. And now we've established that y2 is f of x plus change in x, and I hope you've seen that so that we don't waste much time on that. Minus, what's our f y1? Our y1 is f of x all over. Now we said that x2 is equal to x1 plus change in x. So now that means to find my, if I take this x1 to this side, which is x2 minus x1, that will give me my change in x. Now, why do I have to replace it with change in x? Because if you look at this gradient which I have here, you will not see x1, you will not see x2. So everything is in terms of x or either change in x. Okay, so that's exactly what I'm trying to do. So I don't want to be dragging x2 because there's no x2 here. So in order to avoid that, I will take x1 over to the other side so that I will have that change in x is equal to x2 minus x1. So that settles it. So I have my slope to be equal to, now this slope m is at what point? That is the gradient of this tangent along this tangent. That's why I have my slope m1. But my slope m2 is going to happen here. That's the second slope is going to be happening here. Calm down, I'm coming, I will explain. Now, how is that possible? Now, as B approaches, are you seeing my point A and point B? Now, as B approaches A along the curve, what do you think will happen? If this point B is approaching this point A, it means that this change in x is going to be tending towards zero. How? As B is approaching A, this line will be coming closer, coming closer, coming closer to A. So as it's coming closer to A, what happens to change in x? Remember that change in x, for us to have change in x, for us to have increase in x, that means this cannot be zero. Are you getting me? Assuming here is 1 and here is 2, it means that change in x is 1, right? If here is 2 and here is 4, it means that change in x is what? Is 2. Good. So now for B to move closer, for this B to approach A along this curve, it means that change in x will be tending to zero. I hope you've watched our video on functions and limits. Please, if you've not, can you kindly pause this and then watch that? So that when I use these words, tending to, approaching, all these things, limit, function, you will understand where I am coming from. Okay, so now if that happens, the gradient of the secant AB will also tend to the gradient of the tangent to the curve at B. So the second slope M2 is the limiting value of M1 as change in x tends to what? To 0. Are you getting me now? Good. So now we have We've established that this is m1. So we have limit, which is m2. Limit as change in x tends to 0 of this function minus f of x over change in x. Okay, now so this is what we call first derivative. We call it derivative of f of x. Okay, so now what does it mean? It means that our second gradient, which is m2, will be equal to the limit as change in x tends to 0. Remember that this numerator, this whole thing is simply what? Change in y. The denominator is simply change in x. So our slope 2 is what we call the y dx. Therefore, m2, this whole expression, limit as change in y with respect to change in x. Okay, limit as change in x tends to 0 of change in y with respect to change in x, we call it what? The y dx. That's the one with, this is the spelling, dy dx. So know the difference between dy dx and then change in y with respect to change in x. Okay, so now let's look at a few examples in this video. Understand first principle before we talk about other methods, all right, of differentiation, which we will be treating in our next video. All right, now the first question says find the first derivative of the function y is equal to x squared. Good. Now before we start, we solve this question, there's something I want to show you. Now y is equal to x squared. Remember that what we used to explain these things was the function y is equal to f of x, right? So now for any function given to you, just like this example that says y is equal to x squared, that is our point A, right? So what's the first thing to do? The first thing to do is to find point B. And what is point B? Point B is what? Is x1 plus change in x. That's what our x2 stand for, right? X1 plus change in x, comma, we have f of x1, or let's use y1 plus change in y. That's the point B. Y point A is simply x, comma, y. Point B is x plus change in x, y plus change in y. Did you see that? So that you understand whatever I'm doing, you know where it is coming from. Now, going back to the question, if we have y is equal to x squared as our function, remember, what are we exactly looking for? We are looking for the second gradient m2, which is the y dx. So in order to find the y dx, we need to find the limit as change in x tends to 0 of change in y with respect to change in x, which I just circled. So what do? We have been given point A. These are point A. So the next thing to do is to find point B, right? So our point B is going to be what? Y plus change in y is equal to x plus change in x. We have squared. So this is point B. Okay, now having known point B, what's the first thing that comes to our mind? How do we get to change in y with respect to change in x? That's the first thing. But before then, we need to expand the right hand side. We can't solve leaving it that way. So if we expand x plus change in x times x plus change in x, that should be x squared plus 2x change in x plus change in x squared. Good. There are no like terms to collect, right? Okay. So now how do we get rid of this y here? We subtract y from both sides. And what is y? Y is what? x squared. So if we subtract y from both sides, we will have x squared plus 2x change in x plus change in x squared minus x squared. So doing that, this will cancel out. And when that happens, we have this will also cancel out. We have change in y to be equal to 2x change in x plus change in x squared. So the next thing will now be, what do we do? Okay, we've known change in y. So we need change in y with respect to change in x. So we divide through by change in x. Remember, we have an equation here. So we can't be dividing the left hand side by change in x and then leave the right hand side. So we now have that change in y with respect to change in x, this will cancel out here. So we have 2x. Now this is just like saying change in x times change in x. So this will take one change in x and then we have plus change in x. Are you seeing that we're getting closer to our dy dx? So now we have the second slope, which is our dy dx, to be equal to limit as change in x tends to 0 of change in y with respect to change in x. So remember from the illustration that change in x is tending to 0, right? So that will mean 2x plus 0. So our dy dx is equal to 2x. So anywhere I see x, I'll add my change in x. So I have x plus change in x squared plus 2x plus change in x minus 1. Okay, so I'm going to expand, or let me use the word simplify the right hand side. And if I do that, I will have x plus change in x squared like we did in the first one, give us x squared plus 2x change in x plus change in x squared plus 2x plus 2 change in x minus 1. Okay, so if we simplify further, we will have y plus change in y to be equal to 3x squared plus 6x change in x plus 3 change in x squared plus 2x plus 2 change in x minus 1. Now let's look and see. I think there are like terms that we can collect. Are they? Okay, there are no like terms. Okay, so now since there are no like terms, we continue. So subtracting y from both sides, we will have change in y to be equal to 3x squared plus 6x change in x plus 3 change in x squared plus 2x plus 2 change in x minus 1 minus, remember our x is 3x squared. So since we are subtracting, anywhere I have minus, I will have plus. Anywhere I have plus, I have minus, because the subtraction is for the whole expression. Okay, so now my change in y becomes this 3x squared will cancel this. Okay, let's look for another one. Plus 2x will take minus 2x, while minus 1 will take plus 1. So when we are done deleting those ones, we have 6x change in x plus 3 change in x squared plus what? Plus 2 change in x. So what do we do? Do you remember? With respect to change in x for every term, with respect to change in x. Okay, so now that means that our change in y with respect to change in x is going to be, we have 6x plus 3 changing x plus 2. So our dy dx, which is limit as changing x tends to 0 of changing y with respect to changing x, becomes 6x plus, now that means we're going to substitute 0 here. So 0 times 3 will give us 0. So we have dy dx to be 6x plus 2. And then coming to the last question for today, which is y is equal to, we have a function that y is equal to x raised to the power of n. So now, first with this function, and I hope you still remember your binomial expansion. Okay, we'll get to that. So now let's find our point B. We've gotten our point A. So our point B, which is y plus change in y, is equal to x plus change in x raised to the power of n, right? Okay. Now, when we had raised to the power of 2, it was easy to expand and all that. So faced with the power of n, what comes to your mind? Binomial expansion. And remember that in binomial expansion, you were taught that given x plus y raised to the power of n, that in expanding, you will have x raised to the power of n, and this x raised to the power of n is actually n combination 0. Now, why is it x combination 0? Now, as the first term, which is x, is decreasing starting from the power of n down to 0, the second term, which is y, will be increasing starting from the power of 0 down to n, right? Good. So now, x raised to power n, y raised to power 0, do you remember? Plus n combination 1, n combination 1, x raised to the power n minus 1. Remember that the power of x is what? Reducing, decreasing, until it gets to 0, right? While the power of y will be doing what? Will be increasing. Plus, it will keep happening this way until you get to the last term. Remember that in that last term, x will now be raised to the power of 0, right? X raised to the power of 0, y raised to the power of n, and then you will have n combination n, which will give you what? 1. Okay? All right. So now we're going to be using that binomial expansion to expand the right hand side. I had to take you on this journey so that you will understand what we are doing and where it is coming from. Okay, now applying this binomial expansion on the right hand side, we will have x to the power of n plus n times x raised to the power of n minus 1 changing x. Somebody will be asking, why are we having n? N combination 1 will give you what? Okay, so you help me answer that. Okay, so now we have plus n. Okay, let me just write one more, then I'll put my 3 dots, times n minus 1 x raised to the power of n minus 1. Then we have changing x raised to the power of all over 2 factorial. So this will keep happening until, let's use our 3 dots, 1, 2, plus the last term, which is what? Which will be changing x raised to the power of n. Okay, so what will be the next thing to do? The next thing to do will be to subtract y from both sides. So subtracting y from both sides, we'll have changing y to be equal to x raised to the power of n plus nx raised to the power of n minus 1 times changing x plus n into n minus 1 changing x squared plus changing x raised to power n. So if we minus x raised to the power of n, this will go. And when this goes, we now think of dividing through by changing x so that we can quickly get our dy dx. So now if we divide through by changing x, that means changing x will take this one. Now we have power of 2 here. Changing x will take 1 here. So we will have, as we are dividing, let's be writing out what we have, plus n into n minus 1 x raised to the power of n minus 1 times changing x, plus it will keep going. Now changing x raised to the power n, if we remove 1, that will be changing x raised to the power n minus 1. Okay, so now limit as changing x tends to 0 of changing y with respect to changing x becomes, that means anywhere we see changing x, we should put 0. And mind you that this plus all of them have changing x raised to the power n minus 2, changing x raised to the power n minus 3. It keeps on going until you get to changing x raised to the power n. Okay, so now since all of them have changing x, so we'll have, if we put 0 here, the whole of this expression becomes 0. 0 raised to power anything, 0. So what do we have? That dy dx is nx raised to the power of n minus 1. And this is where we get the general formula for differentiation. So that means that the derivative of x raised to the power of n with respect to x is equal to nx raised to the power of n minus 1. So for any function you have, if I have that f of x is equal to x raised to the power of 3, it means that differentiating x raised to the power of 3 with respect to x, I'm going to have what? My n coming down, I have 3x raised to the power of 3 minus 1, and that will be what? 3x squared. So I believe you've seen where this formula we use in differentiation is coming from. And I want to believe that you enjoyed the video. Please do well to subscribe and reach out if you have any question or you need further clarifications. Join us in our next class, in our next video, and do have a lovely day. Bye.